Good morning, afternoon, evening, whatever time of day it might be. My name is Sam Worthley, and this is my eMachines project video about the multimeter. So today, we're going to be discussing some of the capabilities of this multimeter, specifically AC voltage, continuity, resistance, DC amperage, and DC voltage. Something you may notice about this multimeter is you'll see that there are 3 ports on the bottom here. We have one black port, which is our common lead, and 2 red ports, here and here. The primary port we'll be using is the red port on the right, as it can measure voltage, resistance, and a small amount of DC current. But for any amount of DC current over 200 milliamps, we'll need to use this red port on the left here, which can measure DC current up to 10 amps. As far as safety precautions are concerned with the digital multimeter, one of the most important things to consider is the overall condition of the meter. Just give it a good once over to make sure there's nothing exposed, no damaged parts of the meter before you start using it. Furthermore, it's also important to ensure you have a proper connection between your test leads and these ports here on the meter. Especially when locking out a circuit, it's common practice to perform a dead live check with your meter. This means testing the meter on the energized circuit to confirm the readings on the meter, locking out or de-energizing the circuit and confirming that there is no power, and then testing the meter again on a known live source to confirm that your meter is giving reliable readings. Let's say I want to isolate this circuit with the yellow LED. I'm first going to measure the line voltage across the circuit. You'll see we have 4.84 volts. I'm going to disconnect the circuit. I'm going to confirm that we have 0 volts across the circuit. Then I'm going to also confirm that the meter is still working on a known live circuit. Another safety precaution to consider when using a multimeter is to ensure that it's been approved by independent testing for its designed use. You should be able to find markings like these on the documentation for your meter from independent organizations that test and approve electrical products for safe operation. This ETL marking means that the product has been tested and approved by the electrical testing laboratories of Intertech. This is one of the most common and widely recognized testing organizations. Another thing that's important to understand when using a multimeter is that in order to perform accurate measurements, the meter must be within a range that can measure the applicable values. I'll demonstrate what happens with the meter when a measurement is out of range with the resistance function and this 10 kilo ohm resistor. As you see, I've set the meter to 2000 ohms, and if I attempt to measure the resistance of this resistor, the meter displays OL. Typically, OL means open line, but in this case, the meter is indicating that it's out of range. If I switch the meter to 20,000 ohms and try to measure the resistance, you'll see that the measurement we get is what we're expecting.
When measuring resistors, it's important to understand the color code and what value to expect before measuring. To decode the colors, we can reference a chart like this, which will tell us what the bands indicate and the value associated with each color. For this 5-band resistors, the color is brown, black, black, red, brown. Brown indicates the first digit, which is 1. The first black indicates the second digit, 0. The second black indicates the third digit, 0. The red indicates the multiplier, which is 100. And the brown indicates a tolerance of plus or minus 1% of the indicated value. This means that our resistor should be 10 kilo ohms. In measuring it, we get 9.99 kilo ohms, which is well within spec.
I'll also be demonstrating how to determine if a battery is charged or not with the use of the DC voltage function. When testing a fresh 9-volt battery like this one, the voltage should be about 9 volts if not slightly higher. With the meter set to DC voltage in a range of 20 volts, this battery measures at about 7.32 volts. meaning this battery is nearing the end of its life. Next, I'll be demonstrating the use of a multimeter on a live outlet. The other end of this extension cord is plugged into the wall, so we should be able to measure the RMS voltage coming out of the outlet using the AC voltage function set to 200 volts. I'll put the red probe in the right port and the black probe in the left port. And doing that, you'll see we measure 123.3 volts. I'll also perform a continuity test on an extension cord to prove that it's properly wired and there's no shorts between any wires. After setting the meter to continuity, I should be able to put one probe on the neutral line of the female side and touch the other probe to the neutral end on the male side. Get the audible signal, and we see we have a small resistance. Should be able to do the same with the hot. Sticking one probe on the hot side of the female end and touching the other probe to the hot side on the male end. See, we have a very small resistance. To check for any shorts between any of the wires, I'm going to touch the other end of the probe to the neutral side while this probe is connected to the hot side, and I shouldn't get any kind of reading between them. And you'll see we still have an open line, meaning that there's no shorts between these wires. We can also do a continuity test between each of these outlets on the extension cord. If I go between the hots on each of these ports, you'll see they're connected. We can do the same with the neutrals. And you'll see they are each connected.